5 or so years ago, most manufacturers made the decision to move towards software-defined vehicles, and this took many years to design the architecture and bring together the electrical architecture to make this possible. But today we have vehicles coming out that have centralized compute and the ability to get data off them and deploy over their updates. Governments, many years before the technology is ready, have actually proactively started working on regulation and the capability of our models to understand and not only safely drive, but also simulate and measure the performance of this driving, of course, is compounding in a way that's just ahead of our expectation.
Alex Kendall co-founded Wayve in 2017 to reimagine autonomous mobility through embodied intelligence. Under Alex's leadership, Wayve is one of the fastest growing AI companies for autonomous driving globally. From his award-winning research at Cambridge, he pioneered a new approach to self-driving using end-to-end AI to build a general-purpose driving intelligence that can drive any vehicle, anywhere. As CEO, Alex leads the company's overall strategy, working closely with investors and partners to deploy Wayve's embodied AI software into millions of vehicles worldwide. Alex, how are you doing today?
I'm excited. It's going to be a good conversation.
I think so, because I didn't trip up over your bio. I actually read it perfectly for once. So hopefully we'll continue that trend. And you know what stood out to me in reading your bio? Wow, you've been at this for a while, almost as long as I've been covering the rideshare and mobility industry. You've raised, it looks like $1.3 billion with Wayve. You've got offices in California, Germany, Japan, Canada. Seems like things are going pretty well.
Oh man, it's been a humbling journey. It's been, I think, since we founded the company and many more years before that, working on robotics from my childhood days to university days. But I think the really exciting moment in time now is, well, it is exciting. But the approach that we're taking is transition from going from being very contrarian to now it seems to be somewhat becoming the consensus belief, which is a real privilege. I've been pitching for 8 years that end-to-end AI is going to be how we're going to overcome so many of the limitations of our previous autonomous driving technology. And you know what it's enabling today is remarkable. In the last 3 months, we've driven in over 100 cities around the world autonomously, no maps, just with onboard sensing and compute that you find on standard consumer cars. And our AI has been able to drive places as diverse as the Swiss Alps to the Canadian mountains. It's amazing.
And just to be clear, so I think you're referring to the road show that you've been doing. And what type of car was that? And that's there's no special hardware. It's just your AI software on it.
So specifically, it's our development fleet today is mostly on the Ford Marquis vehicle.
Okay.
So we drive these vehicles across Europe, Asia, North America. And on board that vehicle, we have a single NVIDIA Orin chip. We've got surround cameras and a forward-facing radar. So quite, a lean hardware set. But I guess zooming out, we drive vehicles with camera only, camera radar, LiDAR. And the approach that we've been pioneering is one we call AV 2.0. And essentially it's one big AI model that's trained to be very general purpose, trained to drive with heterogeneous data from different vehicles, different countries, different sensor architectures. And the whole concept is that we want to learn end to end how to drive the car and to handle scenarios that it may never have seen before. Because that's really the thing that we need to be doing in. And the industry is dealing with the long tail of edge cases. And to be able to do that, you need an AI. We're convinced that you need an AI that can deal with things it's never seen before to be able to generalize those new scenarios.
So 8 years ago, let's rewind, if you can even remember that far back. Why did you pick this model? You said you were ahead of the curve, sort of doing this before anyone else. Why were you so convinced 8 years ago that this would be the way of the future?
I had the good fortune of working with some colleagues at Cambridge University, and we wrote the first end-to-end deep learning algorithm for scene understanding. So this is a neural network, very small in today's standards, but we trained it on 300 labeled images from Cambridge, and it was able to take a single image and tell you where you are, what's around you, what's going to happen next, and really understand the semantics and geometry and motion of the scene. What was cool about that is, when I traveled to places around the world, I tried this algorithm and it really worked wherever you were. So it led to the belief that, okay, we can build robots that can start to actually understand their environment for themselves. And at the time, the whole industry was pushing to build HD maps and infrastructure that would tell these vehicles how to drive and respond to scenarios. And so it was, I guess, that coupled with just down the road in London, a lot of friends and people that were inspiring to me were working at DeepMind building AlphaGo. This was a system that learned to beat the world champion at the game of Go, and extraordinarily different game through reinforcement learning. And I guess I could see that more and more complex problems were being solved with end-to-end deep learning. And actually the kind of technology we were building could bring this to the physical world with real world understanding of high dimensional imagery with
Yeah.
this approach. That led to it.
So if we take a step back and look at the AV industry as a whole, I feel like in the past year there's been a big inflection point with a lot more excitement, investment. I started my own newsletter, right, covering the space, and I'm curious what it looks like from you. Has this just been like business as usual for you? Like kind of like a small bump on the road, or have you noticed a change in public perception or interest? Like, what have you seen from your seat? Because you've been doing this for so long.
Yeah, I mean, it's one of those things where so many things are coming together at once.
Hmm.
And it may feel like everything's happening now, but actually it's been many years in the making. I'll give you some examples.
Yeah.
The automotive industry, you know, 5 or so years ago, most manufacturers made the decision to move towards software-defined vehicles. And this took many years to design the architecture and bring together the electrical architecture to make this possible. But today we have vehicles coming out that have centralized compute and the ability to get data off them and deploy over their updates. So that's one thing that's happened.
Got it.
Second, regulation. Governments, many years before the technology is ready, have actually proactively started working on regulation. And for example, here in the UK, we got countrywide legislation passed last year through Parliament that legalizes all levels of autonomy. And that's, the same is true around the world. We co-chair the industry committee at the UN level,
Hmm.
and we're just seeing proactive legislation come in place. And then, of course, on the AI side, the capability of our models to understand and not only safely drive, but also simulate and measure the performance of this driving, of course, is compounding in a way that's just ahead of our expectations. And so all these
Yeah.
things are coming. There are many more. That's making this a really special moment in time, as you described.
Yeah. So the actual end-to-end technology, I think it's pretty cool. I've been following Wave's progress, and you mentioned 3 months, 100 cities. So that was primarily with the Ford Mach-E. There's a safety driver, I guess, behind the wheel, but the actual Wave driver is driving. And I guess to be clear, is there extra hardware on these Ford Mach-E's, or is it just what you would buy as a customer?
So we have retrofitted the compute and sensors on the marquee,
Got
but
it.
it's the same standard of hardware that you find in production vehicles. In
Okay.
this case, in NVIDIA Orin and surround sensors. But we also work with Qualcomm 8650 chips and
Hmm.
other SoCs in the industry. But yeah, that's right. I mean, the whole premise is with this AV 2.0 approach is that it's an end-to-end model that's trained that really overcomes many of the limitations that we've seen so far. So without needing HD maps,
Right.
it had onboard intelligence to drive in places it's never been before. And we can work with lean hardware stacks. And so we work with production
Mm-hmm.
integrated. So the products we deploy won't have retrofit hardware, but
Mm-hmm.
we'll work with vehicles that have inbuilt hardware
Yeah.
that compute those kind of sensing solutions. And of course, this AI is going to power products all the way from L2 to L5. So it'll enable hands off, eyes off driver assistance technologies. And then, of course, general purpose robo taxis that can drive everywhere. And the
Yeah.
AI will underpin all of those.
So I'm not going to make you pick, but I think the two things you mentioned, the lean hardware stack, right, is interesting, right? If it's cameras and maybe cameras plus radar, it sounds like, and then also the mapless aspect. I don't know. Do the two, you kind of need both to be able to deploy this technology, or is one more important than the other?
Oh, that's an interesting question.
I'm sure some customer is going to ask in the future, so this is a good warm up.
Yeah, I mean, there's nuance in both, right? On the map
Yeah.
side, you do need a navigation map. I think the key
Mhm.
difference there is your map a prompt or perhaps a noisy prompt where it can navigate you and give you a suggestion or a guide of how to turn by turn to be able to get to a location. I think that's great and necessary, but we want to avoid a map that's required for the safety case that requires extensive labeling and validation that really tells the car how to drive. So
Got it.
there's nuance there, but you still do need a navigation map. And then on the sensing side, of course, you need to be able to see. You can't have no
Mhm.
sensors.
Yeah.
The key thing there is that we train our AI to know what the sensors can or can't see. And that comes out really naturally because if we're just fundamentally building a world model, an AI that can predict what happens next, if you're a camera only system, of course, there's going to be some limitations of what you can predict that happens next. Whereas if you're a camera, radar, LiDAR system,
Yeah.
and you may, oh, of course, you have a richer modality sense. And so the AI can naturally learn from just unsupervised video data how to predict both understanding, but also what can or can't be
Yeah.
seen by a system. That's pretty powerful.
What are you seeing on the hardware side? We just interviewed John McNeil, ex-Tesla president, who you may know, and he mentioned that, Tesla's original approach, they didn't like the LiDAR aspect because it was so expensive. But now a lot of these, excuse me, chips and LiDAR and all these components, the costs seems like are coming way down. So what do you see sort of into the future on the hardware? What's kind of your ideal stack in terms of, what's best for your model, what's best for your customers, et cetera?
Yeah, so today we work with some of the leading manufacturers and fleets around the world. And what we see is, broadly speaking, a consensus view that, look, camera only can get you I think, a really attractive driver assistance, a hands-off system that it's a comfort and safety system. It can, of course, really, really support you driving point to point around the world. When it comes to eyes off or driverless, though, first products are going to be the way to go is with redundant sensing modality. And most manufacturers we're seeing are building vehicle architectures that typically have surround camera, surround radar, and a forward-facing LiDAR. And that's the kind of stack that it's cost effective enough that you can build that at mass production scale. Certainly, we're seeing this come in the luxury vehicles and the robotaxis, and will proliferate products into more products over time. Longer term, of course, it is possible to build a camera-only system, and I think that there will be optimization pressures that push towards that. But I think given how affordable radars are, or even where some LiDARs are going, I do think that it really depends on the product experience you want. I'll give you an example. Let's say in London here, there's often foggy environments. If it's foggy, do you want the car to slow down? Because you can have a camera-only system drive in fog, absolutely fine. But typically it will slow down because of the limitations on what you can see. Or do you want a product experience that if it becomes foggy, you leverage radar technology and still get the right visibility? Maybe you need to slow down some, but not as much as if it was camera only. And so those kind of product questions really matter.
Yeah.
But for long term, you can build a camera only system, and our AI will certainly support that. But we think the more pragmatic, safe, and more effective path, certainly for early generations of autonomy, is to have that redundant sensing. And that's what we're mostly working with our partners on today.
Yeah, I like that. And I'm definitely no hardware expert, if you couldn't tell by now, but I do like this concept of, Waymo has done a really good job sharing these videos where LiDAR can basically see around a bus. They can see someone coming out before a human eyes can, right? The radar is supposed to be able to go under the car in front of you and sense that, the car in front of you is braking. And then so you start slowing down. That's right, in theory, how some of these are supposed to work. So I just like that kind of concept of, adding a couple hardware pieces that are better than humans, right? That can do more than the eyes, and whether that psychologically feels good and looks good, or and then of course has some safety benefit, I'm sure too.
Yes, and I mean the key thing there though is that it can actually scale, and on that front, it's all about, I think, mass manufacture, avoiding retrofit, working with manufacturers to build products at scale. The other point I'll make is, because software is efficient enough that it can run in consumer vehicles, and because it's generalizable to operate at that scale, the other benefit is that the access to data that provides, the access to regulatory engagement around the world, I think we're going to see hands-off and eyes-off systems in consumer vehicles around the world reach much greater scale faster than robotaxis. And so I think that's going to be really important for us to build a sustainable business, but also access that scale of data. And I'm unsure if you can build a general purpose robotaxi without consumer data, just because the scale and diversity you get from that data is so much greater than scouring a few cities for a robotaxi approach.
Got it.
So we're building the most diverse data sets in the industry today, because we have many different manufacturers, vehicle types across many different countries. And so on many dimensions, volume, countries, vehicle type, sensor architectures, we have a really diverse and rich set of data, and that really aids to the generality of the model that we can build.
Yeah. So you mentioned robotaxi a couple times, and we talked about the camera-only approach. I guess this sort of reminds me the actual AV tech of Wayve is similar to Tesla's approach, right? I don't know if you like that comparison or not, but how do you feel? Is that accurate? And so how do you feel about that comparison? Because obviously that's in the news a lot right now, especially here in the States.
Yeah, it was actually quite refreshing to see Tesla pivot to the end-to-end approach, end-to-end deep learning approach, a couple of years ago. And we share a lot with them today in our technical strategy. We're both, to my knowledge, building an end-to-end deep learning approach to driving. But then, of course, we also have differences. Our focus is on building rather than vertically integrating into our own vehicle. We're building a platform for fleets and automotive manufacturers to use around the world. And we're not religious about being camera only. We do work on some vehicles that are camera only, but of course, other products that benefit from radar and lidar.
Yeah.
So I think, I think ultimately there is an opportunity to build with greater scale. There's about 90 million vehicles built a year around the world. Tesla build a couple of million of those, but there's the vast majority of manufacturers that can't or won't build this autonomy themselves. We would love to partner and are partnering with many of the biggest OEMs around the world to bring these features to market. So that's what I'm really excited about at the moment, the ability for this to really reach global scale and enable a range of products that can benefit different people around the world.
So you've talked about scale a few times, and I think that's one of the benefits, it sounds like, of this model, right? Because I guess first, it's sort of the software only piece, right? So I guess, in tech, where they always say software easier than hardware, scales faster, right? So there's that aspect. But let's talk a little bit about the business model and go to market. I guess, like, how is this model more scalable than other approaches? How and why is it, what makes it more scalable specifically?
It's fun you say that. One of the interesting comments just on software versus hardware is that hardware always comes before software. Like to try parallel develop these, but of course, by definition, you need the hardware before you can run the software. But it's often a point that's overlooked. And I mean, on that point, one of the beautiful things about our approach is that it can generalize to different SoCs, different computers in cars, and different sensors. And that means that when we work with one of our OEM partners, we're not saying, hey, you need to work with our architecture and then reply, okay, there's a 3 or 4 year design cycle to bring that in. But we say, look, the architecture you've spent many years building for this vehicle that you're bringing out next year, we can work with that. We can generalize our AI to your sensing and compute with a little bit of data and then operate on that vehicle. And so that just really adds to the speed and the flexibility, to maybe talk to your main question. I mean, the fact that we can work with manufacturers' existing electrical architecture, the fact that we can form a partnership where we provide the base foundation model and then enable them with the flexibility to build the autonomous driving experience that they dream of, and design everything from the specific behaviors of that vehicle to the HMI, the interaction, the experience. I mean, this has really turned into, I think, quite a win-win partnership across the industry, and something that we expect will become a prevailing platform for the market.
Yeah. So it sounds like the key factor here is that there's a number of OEM partners. Obviously, like you said, they're producing tens of millions of vehicles already. And I guess the hardware is sort of already at the level that you could, sort of apply your software now, or does it need a little bit more?
So today, most manufacturers have vehicles coming out, most of the higher end vehicles that have the hardware you need for eyes-off driving, particularly eyes-off on highway. Some are coming in that has the right equipment for eyes-off urban as well.
Yeah.
And then many more vehicles have the right hardware for hands-off. But I think over time, over the next couple of years, of course, the typical thing is we see that technology move down from the luxury end into more of the mass market.
Yeah.
And so I think we will see consumer vehicles start to have point-to-point eyes-off driving features very soon. And then the difference between a eyes-off consumer vehicle and a level 4 driverless vehicle is actually quite nuanced. From an AI perspective, they can be quite similar, because fundamentally you need an AI that can take liability for driving within a certain set of a certain domain. But for a eyes-off consumer vehicle, of course, you have a different riding experience than a driverless vehicle. So the difference really is less about the AI, more about the surrounding infrastructure. When you think about what is the actual interaction experience of the vehicle, or how does the AI, what is a fail operational state? How does the AI pass control either to a driver in the seat or to remote assistance? And so some of those things and the application really matters, but fundamentally, the AI that we're building will underpin all of these products. And so we are seeing some manufacturers start to build and think about production scale driverless vehicles, not just eyes-off consumer vehicles. And that's really exciting.
Yeah. So I guess the one challenge I see on the scalability side with working with OEMs is that it's a bunch of, first of all, it's a bunch of different OEMs, right? So that's one, you got to work with all of them. And then, of course, they all have different vehicles. And then each vehicle maybe even has different hardware. Maybe it's somewhat standardized. So doesn't that sort of throw a wrench into, you can't just plop the software onto all of the cars at once, right? You kind of need to work with each OEM and then sort of make sure that each vehicle, has the right hardware, I guess that's needed.
Yeah, that's right, Harry. I mean, I wouldn't, of course, we never say it's a simple activity to build a technology like this, but there are a lot of things that we can do to make this a feasible process. Of course, the best OEMs have put in place investments to be able to collect data, and
Mhm.
that's fantastic because that data can, I guess, optimize out the AI for their use case. But there are also a lot of really helpful abstraction layer things that you can do to make this kind of system generalized. Whether this is within different OEMs products, from compact cars to SUVs or whatever they're producing, to different autonomy levels from L2 to L4, or of course between different OEMs. I think the first thing is just making sure that the AI generalizes. There's low requirements around calibration, is flexible to different sensors, and of course, the chips that we work with, whether it's NVIDIA or Qualcomm, I mean, many of them they have fantastic inference engines for deep learning models.
Yeah.
So having the right layer of abstraction can really enable this. And then, of course, the key thing is how do you validate the performance? How do you really prove
Yeah.
that the behavior of the AI is going to meet safety requirements prior to launching that product? And on that front, we found that the way you do that for an end-to-end AI system is very different from a traditional autonomy stack. It's not just a case of collecting a bunch of validation data and just running a structured test through that, but actually the introspection tools, the simulation tools for end-to-end AI are quite different. And we've spent
Yeah.
8 years building that to enable our internal development. And so, I think all of these aspects become really important when it comes to
Sure.
when with technology efficiently.
So, what might the actual kind of go to market look like in this situation? I'm not going to hold you to it and don't need super specifics, but would this be, a higher end vehicle, a luxury, BMW, Mercedes, something like that, that already has a pretty extensive, suite of sensors? How might like this actual go to market look like for this kind of instance of these OEM type partnerships that you're looking at?
Yeah, look, it's natural for new technology to come in through the luxury end of the market
Mhm.
first. We want to very quickly move to mass market. And when you think about this product, I mean, the hardware we described, surround camera, surround
Right.
radar, make forward LiDAR.
I
And
mean, all the luxury vehicles have that now. They've got the highway lane assist, right? And all the cameras and everything.
I guess the point I was making is that as this grows from even just to a camera radar solution with a
Hmm.
hundreds of tops computer, that kind of maybe that's a $1,500 bill of materials.
Yeah.
I think there will be a business case to put that across mass market vehicles because, of course, the level of safety it'll improve on these cars, and then the
Hmm.
time back can give you the improved driving experience. All of these factors will make this a very, very attractive product. And so I expect in the 2030s, if you're building a car that doesn't have point to point eyes off driving, I think the
Yeah.
demand for the vehicle is just going to be decimated. So I think this is going to be proliferated. And then beyond consumer vehicles, of course, all kinds of commercial vehicles, robotaxis, delivery.
Yeah.
Yeah, we really want to see this technology widespread because of the benefits it can bring.
So let's talk about the other side of the coin, which would be more of the shared fleet application. An Uber. You guys, I guess, have a partnership with Uber. They were an investor. How do you describe your relationship with Uber? Maybe let's start there.
Oh yeah, they're such a fantastic partner. They did invest in our Series C round,
Hmm.
and if you look at the speed and strategy they're deploying in autonomous vehicles, it is really inspiring to see what they're making of it. But we're really delighted to be working. I fortunate to have Dara visit last week, Uber CEO, who visited us here in London
Yeah.
and hosted him for a drive, which was magic. But we're excited to be deploying our system on the Uber network. We've announced plans to do this in London. And in general, I think that together we can really build something that's going to be an amazing experience, not just for Londoners, but around the world. Because of course, not needing a high definition map. If you think about the rate that Uber scaled in the early
Yeah.
2010, going to new cities and just really scaling at the speed of operations, like I would like to see once we bring this technology to mass production with our OEM partners, I would love to see that kind of rate of scaling for autonomy, because of course, with no HD map and with the ability to generalize to new markets, it
Yeah.
really does that kind of outcome. And that's what we're trying to build together.
Yeah, definitely. It seems like at a high level, the sort of global scale that Uber operates and the mapless aspect of your technology seem like a great fit. I always like to remind people in the context of AV that Uber does over 30 million rides a day. And people kind of forget that, wow, Waymo does, 30, 40,000 a day and they're scaling so fast. And, but then when I throw in Uber does 30 million, okay, 10 million in the US, 30 million global, right? The scale that they're operating at is pretty insane and massive. So that, I guess, kind of scalability factor makes a lot of sense. How might your technology like actually get into an Uber driver's car in London? How do you see that sort of process happening? And then me as a customer experiencing it, what might it look like?
Yeah, so we're working with manufacturers, and we will license our AI, put it into a manufacturer's vehicle that doesn't have retrofit equipment, but is a mass-produced vehicle, low-cost vehicle with the right sensing and compute for autonomy.
Yeah.
So we license our AI into these vehicles, and it operates on the Uber network. And so it's a real partnership approach where we can move
Yeah.
fast, work with the best in the business on the marketplace side, Uber, and of course the most innovative manufacturers to be able to offer this kind of service. And so these will be commercial fleet run vehicles,
Mhm.
owned and operated by a commercial operator. And yeah, you'll be able to call them through the Uber app, have a Wave pick you up. And I mean, maybe just to
Yeah.
share the experience of driving and say, even just in London, where we just have such complex medieval streets with so many merging and scenarios, it's very different from the structured roads that you see in many places in the United States. The ability for our
Well,
AI
it's
to
an old
navigate.
city. I feel like the old cities are always tougher to drive in, right? Because cars have gotten bigger and, I mean, there were no cars when a lot of these older cities were designed.
100%. I mean, Harry, what's your favorite ride been in a AV or a ride sharing service? Does anything come to mind?
I mean, I'm definitely partial to Waymos lately, here in Los Angeles, taking Waymos everywhere. And, also too, I remember sometimes like I was in Japan, which I know you guys are operating there and have offices there. They've got some really luxurious Ubers over there, the big Toyota vans. I don't even know what model they are. I got picked up in like a beautiful BMW. There's some like really nice cars sometimes in some of these abroad services. So yeah.
Well, one of the things that one of the most exciting experiences I had last year was we have a prototype system called Lingo, which is
Mhm.
a language grounded driving model that we've trained. And not only can it drive you through complex environments like London, but it's also language grounded, so it can communicate with you in text or voice. And so it was describing its drive.
Mm.
I'm pulling around this double decker bus because I can see there's space, or I'm stopping
Oh,
for the
that's cool.
crossing, and it describes it. And you can even ask it questions. You can say, "Oh, what are the
Mm.
risks in front? What do you see? Why are you doing this? Or can you turn left after this car?" And it really opens up this whole new
Oh,
experience where
that's
you
interesting.
interact with your self-driving agent. You can ask
Yeah.
the question, build a trust, and delegate tasks to it. I think that's how the future of robotics is going to work.
That
Once
yeah,
we learn.
I haven't heard anyone describe it in that context. I know a lot of the Chinese AVs have done a really good job with the voice commands and being able to open and close and turn the air up and down and especially helpful for people with disabilities. But yeah, I think there's also the physical or not physical, but the kind of more person to person interaction beyond like the voice functions of the cars. So that is definitely interesting.
Awesome. But we should for a drive
Yeah,
because
no, I'm excited. I'm excited. It's cool to talk about a lot of these services. And then of course, when you can actually take a ride, I think that's one of the, big reasons why the AV industry is having such an inflection point. People are being able to finally experience it and not just talk about it. So I think this Uber partnership is very interesting. The personally owned vehicles, I guess on the kind of, it's sort of similar in a way though, right? Because you kind of need to work with an OEM either way, get your technology in there, and then it's sort of applied. How do you think about I guess your customers are the ones who kind of have to decide if it's worth it. Like, I guess the approach with shared fleets is you can kind of, get the cars driving around all the time, get really high utilization, and it's a good business model from that perspective. How do you think about like that personally owned vehicles for, the application of your services versus a shared fleet? Is one better than the other, or they kind of work in parallel?
look, I think the world has so much diversity that there's going to be reasons for both applications. And so
Hmm.
it's not a question of one or the other. Cities are going to need both public
Yeah.
transport, personally owned vehicles, ride sharing vehicles. And I think the key thing is that all of these applications can benefit from autonomy. I think in general, we will see more of a trend towards shared vehicles and commercial fleets, but
Hmm.
it's not going to remove the need for personally owned vehicles.
Got it.
There's going to be a mix and they'll all benefit from autonomy.
Well, because if I think about it technically, right, your mapless solution is great for, expanding, Uber expanding into a bunch of different markets. But within a market like London, I mean, all of the rides are happening in a very high density area, right? You could almost go and map that area and get a pretty good ROI there versus if I have a personally owned vehicle and I've got Wave's technology in there, I drive in the city, but then I want to drive to another town. I feel like that's where it starts to become really valuable. So I don't know, I see the case for both, like you said.
Yes, and when you have such a dynamic environment like London, it's
Hmm.
very hard to drive relying on a map prior. You need to be able to deal with all of the dynamic and complex nature that you see in front of you. But that's right, and ultimately, I think there's going to be some fleets and manufacturers that build their own stack, but there's going to be a place in the market for a
Hmm.
platform. And the requirements to succeed as a platform is, of course, you need to generalize, you need to scale, and yeah, need to be able to deal with just the sheer diversity of different autonomy
Yeah.
products that partners want to build. And I think Wave is really well positioned to offer that to the world. It's exactly what we're building and what this technology enables.
Definitely. Well, that's a great note to end on. And Alex, I really appreciate you coming on the podcast and giving us a bunch of information about Wave, what you're up to, and what the future lies ahead. And I will be holding you to that ride that you offered me at some point in the future.
Let's do it, Harry. It's a great conversation. Cheers.
All right. Take care.